Hi, welcome back. We're going to talk about a device called the Atwood Machine, and we use it a lot while we're studying Newton's laws, and we can actually do some interesting things with it. Okay, let's go ahead and get started. So the Atwood Machine is just two masses hanging on over a pulley. The more massive of the objects, or the heavier of the objects, uh, causes the system to accelerate in its downward direction. If we collect the right data, we can actually measure g, measure the acceleration due to gravity. Now, for this Atwood machine, we're going to drive an equation which can be used to find g, the gravitational acceleration from a measured value of acceleration. Okay, so I'm going to start out by drawing a free body diagram of our system. Remember, the pulley just bends the axis. So this is my system. And the box represents the string, really, the connection between the two masses. And we're going to assume that mass 1 is larger than mass 2. The force going to the left would be mass 1 times the acceleration due to gravity, and the force going to the right would be mass 2 times the acceleration of gravity. And if we are assuming that mass 1 is greater than mass 2, that means that the mass 1 is going to go down, mass 2 is going to go up, and if I'm pretty sure that's the direction of motion, that's also going to be the direction of my positive x-axis. That way my acceleration will be in the positive direction. It just makes the math a whole lot easier if we work this out. So the next step is to write the Newton's second law equation of motion. Sum of the forces in the x direction is equal to the mass of the system. So the mass of the system is the sum of the two masses, m1 plus m2, times the acceleration of the system. And that is equal to the sum of the forces acting on the system from our free body diagram. In the positive x direction, there's m1g minus the forces acting in the negative direction, m2g. And let's go ahead and solve for the acceleration. But Mr. Miller, you said we were going to solve for g. This looks like a mess. How the heck are we going to, or not solve for g, but find g? How the heck can we use this to find g? Well, fair question. I see in the numerator that g appears in both terms, so why don't I factor that g out of those two terms, and my equation will now look like this. And I factored out of the numerator, and so that will be g. So g times m1 minus m2 over m1 plus m2. And I'm going to clean this up just a little bit so it should look more like an equation that you're used to seeing, which is y equals mx plus b. So if I make my y value the acceleration and my x variable m1 minus m2 over m1 plus m2 and multiply that by g, that would lead me to believe that the slope of this line, if we were to graph this line, would be g. That might be useful because we can measure the acceleration of this system using kinematics, using sensors. We can measure the masses of the two objects hanging on the string using a mass scale or some other means. And if we could graph these two things, then the slope of our graph would be g. That could be pretty handy. Let's see what's up next. Multiple choice question. Welcome back. Well, I set this up so that you would be ready to do the lab when you get into class after watching this video. So, Atwood Machine pre-lab to determine gravitational acceleration using the Atwood Machine. Theoretical background, we just went over that. That's what we did on the previous slides. And what's your procedure going to be? That's for you to decide. Assume that you're going to have a pulley, stopwatch, meter stick, maybe a motion sensor, string to mass hangers. How are you going to collect enough data so that you can measure G? And then data. What data are you going to collect? You need to make data tables so that you're ready to record that data. This is probably the hardest part of the whole lab, is for you to decide what data you're going to collect. The equation that we derived in the previous slide should guide you in what data we need to collect. Let's see what's next. Next up is your free response. Complete the pre-lab, fill in the blanks, and pay particular attention to writing down what data you're going to record. Maybe make a data table that you can use while conducting the lab. Good luck. We'll see you in class.